Hello students, I am Vikram Singh Rathod. Today I am presenting a video on supervised machine learning algorithm. We will now review the most popular machine learning algorithm and explain how they learn from data and how they make prediction. We will also discuss how the concept of model complexity play out for each of these models and provide an overview of how each problem build a model. We will examine a strength and weakness of each algorithm and what kind of data they can best be applied to. We will also explain the meaning of the most important parameters and options. Many algorithms have a classification and regression variants, and we will describe both. It is not necessary to read through the description of each algorithm in detail, but understanding the model will give you a better feeling for the different way machine learning algorithms can work. This chapter can also be used as a reference guide. You can come back to it when you are unsure about the working of any kind of algorithms. In next slide, I am describe some sample data set. We will use several data sets to illustrate the different algorithms. Some of data set will be small and synthetic learning made up, designed to highlight particular aspect of algorithm. Other data set will be large real world examples. An example of synthetic two-class classification dataset is the forged dataset, which has two features. The following code create a scatter plot. In our next slide, define a picture. Figure 2.2 visualizing all the data points in dataset. The plot has the first feature on the x-axis and the second feature of y-axis. As is always the case in scatter plot, each data point is represented as one dot. The color and the shape of dot indicate its class. In this program code, we generate a dataset. We use a two variable x and y and call a machine learning library mglearn dot dataset dot makeforge. Makeforge is here a dataset, and then plot the dataset. Then define mglearn dot discrete underscore scatter x coordinator जो कि which is start from 0 and y coordinator which is start from 1. Then plot the legend. Legend means the name that is defined on a graph, and then after plt dot x label first feature, and at the y axis we define the second feature. Then print x dot shape dot format, print xf, and the output is xf is 26 comma 2. Here is a 26 is the number of rows and 2 is a column. It's then after a slide is show the dataset in figure. You can define here. See that the blue 0 dots describes the class 0 and the triangle dots define the class 1 datasets. As you can see from xf, this dataset consists of 26 data points which two features to illustrate regression algorithm. We will use the synthetic wave dataset. The wave dataset has a single input feature and continuous target variable or response that we want to model. The plot create here. Figure 2.3 in our next slide show the single feature of the x-axis and the regression target of output as on the y-axis. So we can write the code here mg x comma y mg learn dot dataset and make wave and put the n samples is equal to 40. Then write the code below. plt dot plot x comma y comma 0 are as a arguments, and plt dot y axis lim minus 3 and n3 two arguments are put, and x label define features and y label define target datasets. So you can see at the graph The x-axis is define here features and the y-axis is define the targets. In this data set or picture wave data set, with the x-axis showing the features and the y-axis showing the regression targets. We are using these very simple low dimensional data sets because we can easily visualize them. A printed page has 2 dimensions, so data with more than 2 features is hard to show. Any initiation derived from dataset with few features, also called low dimensional dataset, might not hold in dataset with many features, high dimensional dataset. As long as you keep that in mind, inspecting algorithm on low dimensional datasets can be very instructive. Thanks.